One.
All right, everyone. So, welcome to today's stream. So, today we will be discussing forces, and currently there's still 4 minutes left for me to start the class. So, let's wait a few more minutes. To make the let's wait for a few students to join in so that they don't miss anything because we haven't officially started by this time yet. If there's anything that you need to ask from the previous class, then this will be the great time. So, let's see. In today's chapter, we will be discussing about forces in general. Well, we will talk about more in depth about forces in the upcoming classes, but I will give you a slight idea of what forces are, and I will introduce you to the topic at hand. Let's see. Hello, Ranjit. Hello. Yeah, I was waiting for a few students so that I will start after everyone joins in. If did you attend the previous class, Ranjit? Hmm? It's nice to have you here, by the way. Let's see. Let's wait 3 more minutes till a few students join in, and let's begin. After that, uh, 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 if there's anything that you need to ask, please feel free. Okay, no. Okay, is there anything you need to ask, Ranjit, on the topic or anything? Because this will be a live session, and you will get to you will get you will get experience from learning. Let's see. Nice. Oh, okay. All right. Let's see. It is two moments are left. 5:58. Let's see. I will do forces today. Basically, I will talk about equilibrium, mainly a part of vectors and forces, but it will be a pretty easy chapter, introductory topic. That will be my topic today, forces in application, right? As you can see. Let's see. Let's see. 5:58. How many minutes are left? 2 minutes are left till we start the class, right? Okay. So, how are you, Anjit? How was the festivals? How was Diwali? Let's see. 5:59. 1 more minute left till we begin. All right. I'm a new student. I have no or never heard no coaching. Okay, that's perfect. That's perfect. You can, learn for free. I mean, that is what I mean, that is why we are here. Uh, in today's class, we will be doing. I'm going to show you the lesson plan. So let's begin in. Let's see. Let me just start. Let's see the timing. Yeah, let's begin in 10 seconds. 10, 9. Okay. Yeah, okay, you're in Telegram group. The group. That's great. That's great, Ranjit. Let's begin in 5, 4, 3, 2, 1. Let's go. Okay, so let's start the class, right? In today's class, we will be discussing about forces in equilibrium, analysis of a particle in equilibrium, and friction. This is the lesson plan for today. This is what we will be discussing in today's class. This is from the vectors chapter. Uh, so we have discussed the previous chapter, the previous topics in the previous class. So now we will move further, and this is everything is some type of fresh. Everything is fresh in this topic. So no worries if you haven't attended the previous class. So let's dive in, right? So let's talk about forces in equilibrium. What do you mean when I say forces in equilibrium? Okay, let's go. You might have studied about forces in class 9th. Now, what do you mean by forces? When I what does come what is the thing which comes to your mind when I talk about forces in general? You might think that forces, force equal as ma, right? This is the basic law which comes into everybody's mind when I talk about forces. You might also see that every action has equal and opposite reaction, third law of Newton. This is also something which, which pops into my head when I talk about forces. So this is, this is the thing which comes into our mind when I talk about forces, but we will not be concerned with this, right? Because in our topic, in our, in our area, the force is in equilibrium, the acceleration, total acceleration, let me write it this way. Total acceleration, uh, x, okay, let me just remove this. Total acceleration will be equal to 0. If you have any questions while I'm teaching you, you can ask me. You feel free to ask me because I would be happy to answer. Total acceleration in this topic, in our course today, when we talk about equilibrium, total acceleration will be equal to 0, right? So if total acceleration is equal to 0, then total force should be equal to 0, right? Keep this in mind. I am talking about total force. When I'm talking about total force, I emphasize on the word total. That means net force on the object will be equal to 0. But if it was 0, then why are we talking about this, right? If it is 0, then why are we talking about this? The thing is, net forces are equal to 0. That means sum of all forces are equal to 0, right? So what do we mean by that? We mean that sigma, sum of all forces, sigma, all forces is equal to 0, right? That means sum of all forces should be equal to 0. Now, how can sum of all forces will be equal to 0? Suppose I'm applying force on the left side and you are applying force on the right side, then it will be equal to 0, because you're pushing the object, uh, from equal, we're pushing the object from opposite sides, and we applying somewhat equal force. You might have played the game of tug of war, in which you pull a rope and the other person also pulls a rope, right? uh, so it is a popular game when you go into NCB and NDA. So it's more of a popular game. We always play it. So in a tug of war, you pull the rope from here, and other person pull it from over here, and you can see that they are all struggling. They are pulling the hardest, but still the rope is not moving sometimes. Why is that? Because the forces are in equilibrium. Everyone is pushing. Everyone is pulling with equal amount of forces. And when the equilibrium breaks, that means when some force becomes weaker, the other force, pulls the object. That means the force will break the equilibrium. But we're not talking about that one point in which the forces break the equilibrium. We're talking about this. We're talking about the point where sum of all forces is equal to 0. Now, how can they be equal to 0? Remember last time we studied about vectors. So it's the sum of all. Now, force is also a vector, right? Force is also a vector quantity. Vector quantity. So that means it has magnitude as well as direction. Important thing is direction. Quantity. Now, if it is applied in the right direction, right, it can cancel each other out. For example, look at this object. Look at this object. We are applying forces from over here, and over here. But sum of all forces turns out to be 0. Maybe the resultant of F1 and F2 cancel out F3, and that is probably what would have been happening in this object, because the resultant of everything cancel out each other. That's what forces in equilibrium means. So let me just write down a proper definition so that you get the idea. A definition for NCRT. What is the definition? You need to learn about the definition in order to proceed further, because sometimes they will ask the definition straight out of the book, and you need to know them by heart. So let me type down definition. Okay. So a particle is said to be in equilibrium, equilibrium, yep, equilibrium, if it is at rest, right? If it is at rest, or moving with uniform velocity, with uniform velocity, all right. How, you will ask me how's it moving with uniform velocity, because let me just emphasize what we mean by uniform velocity. That means v does not change. V velocity does. Sir, in course I got which chapter? So this chapter is vectors. It is a new chapter. You should know about this chapter before diving into any other chapter, because this will serve as a foundation. I think in NCRT this is chapter 4 or 3. I don't remember correctly, but this is the chapter which should be taught uh, before anything else, so that you get the idea. This is around first or second chapter for you. This is basics, so you should know. I'm teaching you this because you should know this. All right. So that means, so let me just emphasize what uniform velocity is. That means velocity does not change. Velocity does not change. And if velocity does not change, that means A is zero. Total A net is zero. That means F net is zero. That's what I was saying. That means F equals to MA. By the way, whatever I'm writing on this board, you should write it down. You should copy it down, because if you, when you are studying on your own, when you are doing self-study, you might look into your notes and see which topics you might have missed, or which topics are your weakness or something like that. But you should write everything down which I'm writing. Write it down, because this will help you when you revise this topic further. All right. So basically this is force in equilibrium. Let's move on. Okay, let's move on. Problem solving technique. Let's see. In this chapter, we need to know how to solve a problem. I will be teaching you the problem solving technique for most of the basic problems which I encounter, because we need to know how to solve a problem. That's what that's what we need to understand when we are dealing with joint entrance exam, JEE. So what is the problem solving technique in this case, right? Let me just write it down. There are a few rules which we need to remember in order to understand how to solve a problem. So let me write down the first rule. That is, sum of all forces, as we all know, sum of all forces, all forces equals zero. Now, what do we mean by that? Right? Sum of all forces, sum of all sigma of all forces. No, I am not from South. I am from North India, Himachal Pradesh, actually. But I am teaching in English because many students might be from South and they would need to understand in English. That's why I'm teaching in English, Ranjit. I can understand Hindi, but you understand, that is why I'm teaching in Hindi. You understand, right? Because some students are from South India, and they might not be comfortable with Hindi as much as they are with English. So that's why I'm teaching in English. All right, so let me just continue this. I'm gonna answer your queries later. Sum of all forces. What write, Ranjit, write this down, because this will help you in solving questions, as you need to know how to solve this. Sum of all forces on x-axis will be equal to 0, right? That means I'm from east. Okay, not okay. That's great. I am going to talk about that later after I finish teaching you this. That means all forces on positive x-axis is equal to is equal to all forces on negative x-axis, right? So this is what is the basic of this chapter. This is the basic crux of this chapter. Which condition works for equilibrium position? Yes, this only works for equilibrium position, because as we know, in equilibrium, sum of all forces is equal to 0. And for that to be 0, sum of all forces on the right side should be equal to sum of all forces on the left side. That is what equilibrium is, right? So this is what I've written. This is nothing but sum of all forces. This is nothing but, right hand side should be equal to left hand side. This is just that. This is just RHS equal to LHS, nothing else. So in this in equilibrium, this is a very easy topic if you understand this correctly. This is a very easy topic and you will understand this correctly. I have no doubt, because this is one of the basics, and if you understand this correctly, your journey in physics will be easy and you will understand every other topic with with ease. You will have no difficulty in understanding them, because if you have your basics strong, if the foundation of a building is strong, then that building could reach skies. It will be a skyscraper. That's what I'm trying to do. Keep your foundation strong. If you have a strong foundation, then there will be nothing that can stop you. All right, let's move on. Let's move to the next rule. That is, this was the first part. The second part is just like this. Sigma of all forces on y-axis equals 0, right? So this is just like this, nothing new. Just all forces on positive x-axis equal to all forces on negative x-axis. Sorry, this is just like that. All forces on positive y-axis will be equal to all forces on negative y-axis. Write it down, because writing down everything ingrains it on your brain. It will make a tattoo on your brain, right? It will be permanent. Keep this in mind. All forces on positive y-axis equals all forces on negative y-axis, right? This is the rule. Write it down. If there's anything you need to ask me, then go ahead. But please be sure to write it down. And after you write it down, when you do your revision, you should keep this in mind, that when you do your revision, everything should be as clear as day. And you should also try to write this down again without seeing your notes, because it will make you remember things in a faster manner. Because when you're studying for JEE, you need to be able to remember things. You need to be able to have memorizing power. Okay, so Ranjit, you're from East. It's nice to have you here. Actually, it's amazing. I love East India. I have been to Jagannath, but let's move on further and let's do a small example. When we do examples, we have our knowledge solidified. We can understand everything if we do examples, right? So after a topic, we should always try to do examples, right? In this course, kinematic is the first chapter. Yes, kinematic was the first chapter, but kinematics uses the concept from this. I cannot say this is a chapter, but this is as per the topic. I'm teaching you this topic because I know from experience. I have given JEE exam. I even got more than 250 marks in my attempt. So I know from experience that this topic is necessary before we begin kinematics. So this is like the basics. This is before that. So believe me when I say this is very necessary for you to understand kinematics, because in kinematics you will encounter relative velocity. Now, how will you deal with relative velocity if you don't know vector? So that is why I'm teaching you this, vectors and forces, right? Okay, so let's do this example. This is a pretty straightforward example. There's nothing new about this. You might have done this previously, but let's see. The sum of three vectors shown in the figure is 0. What is the magnitude of vector OB and OC? What do we mean by that? It means they are in equilibrium. Sum of three vectors are in equilibrium. That means OB plus OC plus OA. Let's write it down. Okay, let me erase this. Pen. OB plus OC plus OA would be equal to 0, right? And now this is vector. So what were the rules? So let's look at the rules again. Rules were somehow all forces equal 0. All forces on plus x-axis equal to all forces on minus x-axis. All forces on y-axis plus y-axis should be equal to all forces on negative y-axis. Let's look at this. OC is out of axis as we can see. So let's make it, let's make it along y-axis and x-axis. How about that? Right. So let's see. Let's take OC component along y-axis. OC component along y-axis shall be equal to y-axis would be equal to OC sine theta sine 45. What is theta? 45 sine 45. Okay, you can do this example on your own while I'm teaching you. You can try this on your own. It will be wonderful. So OC sine 45, OC component along y-axis is equal to OC sine 45. That is equal to OC root 2, right, along y-axis. That means let's just write it as OC along y, right? Let's just write it that OC, yeah, OC along y-axis. Okay, we can hear some disturbances, but no worries about it. So OC along OC component along x-axis, component along x-axis shall be equal to OC cos 45, right? OC cos 45, that is equal, that is, what do we mean by this? What do we mean by this? OC cos 45, that is OC by root 2. Again, so this is OCX. Now, x-axis should balance each other. That means OCX, OC by root 2 equals OB. Let's write it down here. OC by root 2 shall be equal to OB. And also OCY, that means this thing, shall be equal to OA, that is 10. OA, that is equal to 10 Newton. So OC, what is the value of OC from this? Let's look at this. What is the value of OC from this? OC will turn out to be, let me remove something. OC why use cos in the second? Yes, very good question. We use cos in the second because it is component along x-axis, right? Because look at it this way. Suppose we have a triangle. Which is like this. This is like perpendicular. This is base. This is hypotenuse, right? This is clear. So what is we need to find base. We need to find base in this case. So base, what is cos 45? Remember, sorry, what is cos theta? Suppose this is theta. What is cos theta? Cos theta is equal to base upon hypotenuse, right? Keep this in mind. Cos theta equals base upon hypotenuse. Now, how do we find base? Base equals h cos theta, right? And we found a perpendicular in the first case. We had perpendicular in the first case. So what is perpendicular? Perpendicular, what is sine theta? Sine theta is equal to perpendicular upon hypotenuse. What is perpendicular? Hypotenuse into sine theta. So that's why we use sine theta in the first case, because we were finding the y component, right? We were finding the perpendicular. And in the second case, we are finding the base. That's why we use cos theta, right? I discussed this in the previous class. Watch that lecture 2 after this one. But if you have if you have questions in the middle of the class, I will be happy to answer. But remember this: we are finding perpendicular in this case, as we are finding the y along y-axis, right? We are finding component along y-axis, and in this case, we are finding component along x-axis. That's why I used that's why I used the cos theta component. Right? That's why I used this component. Yep, that's why I used this component. So I hope this is pretty clear at this point. If not, then feel free to ask me. I would love to help you further. B is equal to h cos theta, but in our case, theta is equal to 45. So cos theta equal to sin theta in this case. That means we don't have to worry about that. But sometimes it can be 62. It can be 60. So you need to worry about that at that point. But just make a triangle in your head when you're doing this type of questions. You would have no problem dealing with components, right? So OC by root 2 equals OB. And we have OC by root 2 equals 10. So let's talk about this over here. All clear? Perfect, perfect, perfect. OC equal 10 root 2. Right from here, we jump to this conclusion. OC equal 10 root 2. Now we can find OV. What is OV? OV equals to OC by root 2. That means 10 root 2 by root 2. What is OV? Root 2 by root 2. That is equal to 10. Amazing. Right? We have found the OB. We have found OB. Right? We have found OB. And we have also found OC. Our example is done. This is the basic example which I have done to demonstrate to you how we proceed in this type of questions, how we proceed when in the questions dealing with equilibrium. That's why I have shown you this example. There are various other examples which I will come across when I'm dealing with when I'm doing practice questions. Suppose I am doing practice question, right? I'm dealing with if I'm dealing with previous year question paper, then I will come use example like these, because these examples will solidify concepts in your head. So let's move on further and talk about an example 2. Amazing, right? If the resultant of 3 vectors is 0, then the magnitude of one vector must be equal to the sum of the magnitude of other two, right? Okay, let's not jump to conclusions now, because we all know that we are not dealing with magnitude when we are dealing with vectors, because vectors also have direction. What is vector? Well, let's just write it down again. Vectors have magnitude plus direction. A. Okay, very fast. Let's just analyze the other options too before we move further. The magnitude of one vector must be equal to sum of magnitudes of other two. Okay, let's wait a minute. Magnitude of each vector must be greater than the sum of magnitude of other two vectors. Sometimes this may be true, sometimes this may be not true. The magnitude of each vector must be less than the sum of the magnitude of other two vectors. The magnitude of each vector, that means A should be less than B plus C. No, that cannot be. A should be equal to sum of magnitudes. So this cannot be true. But as we have said, my dear Ranjit, the magnitude of one vector must be equal to the sum of magnitude of the other two. A should be equal to B plus C. That's what we're saying, right? This can be true. Sorry. All the three vectors must be of equal magnitude. Nice observation right there. So A and D could be right. A and D could be right. How? This is like, sorry D. No. A and D could be right too. Think about this. A and D could be right too. Both can be right. You were right in both cases. Both can be right. Let's see about this. Magnitude of each vector must be greater than the sum of magnitude of the other two. That means A should be greater than B plus C. Does not really make sense, to be honest. But let's just, let's see. These are wrong. Okay, let's consider them wrong. And let's move further. The magnitude of one vector must be equal to the sum of magnitude of other two. Yep. Okay, this can be the case when we're dealing with, suppose A is like this and B is like this, and suppose C is like this. C is like this, right? So the magnitude of A and B, will be equal to the magnitude of C, but the direction will be opposite. Right? So this can be true. This is true. You were right the first time too, and you are right the second time too. all of the three vectors must be of equal magnitude. Now, how is this possible? This is very interesting. I mean, this is the perfect case, right? Suppose something like this is happening. Let me erase something. Erase this. Okay. Suppose something like this is happening. We are applying force here, right? And some other object is applying force here, and it is also applying force towards here. Now these are all separated by the angle of 120 degree. 120 degree, 120 degree, 120 degree. So if they are all of equal magnitude and they act on each other at 120 degree, then they will cancel out. Don't believe me? You can take the component and you will see that they will cancel out, because let's just look at it this way. So if I draw a line over here, then this will be 60, right? This will be 60, this will be 60. So the y component, and they are of equal magnitudes. Let's just say they are a, right? No, not like that. Okay, because we cannot name the same. They're not the same vector, but they are of equal magnitude. Then the y component would cancel out. Y component would cancel out. Y component would cancel out. Think about this. You're applying force in this direction, then the y component will cancel out. The y component, that means, okay, you're applying force in this direction, that means the y component will cancel out. The component pointing towards each other will cancel out. And if they are same forces applied at the same angle, then they will surely cancel out each other. The y component will cancel out each other, and x component will mix. And when the x component will mix, the most amazing thing will happen. So what? Suppose the magnitude is k, right? Magnitude is k, let's say. So k cos 60 plus k cos 60 should be equal to k, right? Right? 2k cos 60. Sorry. All right. Let me write it down this way. K cos 60 plus k cos 60 should be equal to this one, right? K should be equal to k, right? Because we're dealing with equilibrium, right? Sum of all forces on the right side should be equal to sum of all forces on the left side, right? Nothing too serious. What is cos 60? 1 by 2. K by 2. K by 2 plus k by 2 is equal to k. We have reached the conclusion, and D is the right answer too. So if there were two right, if it is a question from JEE Advanced and we need two right answers, then this will help. Let's see, analysis of a particle in equilibrium. So this is the, we have moved further. We have moved onwards from that topic, from examples, and let's dive into the theory again. Let's analyze the particle in equilibrium. What happens when a particle is in equilibrium? Let's analyze this, and let's talk about this in a little bit more detail. Because if we know detail about what is happening in a particle when it is at subject from equal forces, then you can surely say what will happen to it afterwards. So Fg equal mg equals W. Right. So this is the weight of a particle. So this is the weight of a body, basically. So let's talk about the weight. What is weight? It is always, let me just write it down, the definition. You should write it down too. It is always directed downwards. Directed downwards. Right? Because of course gravity is pointing downwards, weight will also point downwards. It is not like gravity is pointing downward and your weight will point upwards, then you would start flying, right? That would be wonderful. But it is pointing downwards. It is always directed downwards, right? And it is equal to mg. It is equal to mg, right? Mg, if there's anything you need to ask, till that time. So it will be equal to mg. All right, so this will be equal to mg. Let's see. W equals mg. So keep in mind that this is mass M means mass, and G is the acceleration due to gravity. Acceleration, all okay, perfect. Acceleration due to gravity, right? That is Fg equals mg equals a loop. So this is called weight of a body. F equals mg. Pretty straightforward at this point. You might have studied this in class 9, nothing new, but I am telling you this because this will come in handy when we are dealing with other questions. This is weight of the body. It is pointing downwards. Okay, F equal to mg plus equal to, write it down by the way. And if you're not able to write down anything, then after the stream you can watch this after when I'm done teaching, you can watch the stream again and write it and take notes from there. But keep sure to go along with me. Let's move on further and see what is the next topic, that is tension in the string. This is interesting because this is a new topic. You have not studied this in class 9, so this will be new to you. So what is tension? Okay, so whenever a body is connected to a string, right, whenever a body is connected to a string, the string will also pull the body upwards. For example, a block is connected to the string. The block is pulling the string down, but the string is also pulling the block up. So that force which the string exerts on that block while pulling it up is called tension. Basically, that's it, right? It's a lot more. It's a little bit more to digest, but imagine it this way: block is pulling the string down and string is pulling the block up. The force which the string applies when pulling the block up is called tension. That is, the tension in the string. So let me just write down a proper definition, right? Because of course you need a definition for NCRT. So let's just write it down. Whenever a block is connected by a string, by a string, it is pulled by the string with a force. It is pulled by the string. It is pulled by the string with a force called tension. Right? So basically tension in the string. You might have heard the term tension when you are pulling the string, or when you might have seen something like when you're pulling something hard, then it gets very, how can I say this? It gets very wiry like. It acts like a wire. It has tension in it. That means you cannot displace the form of the string when it is tied to a heavy object. That means when it is being stretched, you cannot alter the form because it is very tight at this point. That is called tension in the string, right? So you can try this experiment at your home. So tension is not equal. We cannot define what tension will be, unlike weight, because we can define what weight is. Remember, we can define what the weight of a body was. Remember, it is like equal to mg, mass into gravity. But there's no such thing for tension because tension can change, right? Tension can change. Suppose there are two strings which are pulling this object upwards, and there are two strings that are tied from different angles. Angles would change the direction of string of tension. Basically, tension is a force which is which can be variable depending on the condition, right? So let me write down one more condition. Let me write down one more condition when I talk about this. So what is the condition which I'm writing? Is that first condition this. Second condition is that strings. This is interesting because this will come and helpful in many questions. Strings will be considered okay, let me just erase that. writing perfectly in 3, 2, 1. Yeah. Considered, strings will be considered massless unless stated otherwise. Otherwise. Now, why it considered massless? Because if the string is not massless, then the string will exert different tension. Think about this. If the string has mass, then then as we go down, more weight will be on the string. For example, consider this as the string. Okay, consider this as the string, right? It has mass. Okay, it has mass. Suppose it is a chain. You might have seen chain, right? Chains have mass. Suppose it is a chain, right? Something like this. So when we go further down, the amounts of links on the chain increases, right? And the amounts of and if the amount of links on the chain increase, the mass of the chain will increase. For example, if you pull the chain from over here, right? If you pull it from over here, then you will only experience this mass, right? This mass. But if you pull the chain from over here, you will experience this mass. Right? The mass will change, and so will the tension. And if we analyze the tension at this point, then it would be the whole chain in itself, right? Sorry for the drawing, but you get what I'm saying, right? It is like that. So strings will be considered massless unless stated otherwise. All right, this is pretty straightforward. If you want to note down something, go ahead. I'll give you 5 seconds. I think you might have noted down everything. So let's move on further towards the next topic, which is called normal reaction. All right, nothing to worry about there. Yeah, normal reaction. What is normal reaction? So whenever two surfaces are in contact, they exert a force against each other. That is called basically normal reaction, right? That is, they exert a force against each other that is opposite in direction, and it's called normal reaction. It's basically Newton's third law of motion. What is third law? Newton's third law of motion, Newton's law of motion, third law. Oh yeah. Unless stated otherwise. Otherwise, let me write it down in a perfect manner. Yeah, this was written otherwise. I think my face might be covering this, right? Unless stated otherwise, right? Unless stated otherwise, because yeah, of course, that is what I've written. So I hope you've written this. Unless stated otherwise, let's move on. Okay, I was talking about normal reaction and what does it mean. I was saying that it is basically Newton's third law of motion. What is that? What is that? What is that? What is that? That is the third law of motion states that third law is basically to every action there's equal opposite reaction, but it is somewhat more complicated. That is, if we apply force on an object. I'm giving you a improper definition. Don't take this as a proper one, because this Newton's third law, can be interpreted in many ways. But I'm giving you a definition which suits this chapter, right? But this is near to the perfect definition, right? You can use this in NCRT if they ask you. Basically, it's like if an object applies force AB in an object, and the force B, if the object A applies force F on an object, and object B will also apply the force minus F on object A. That is what the law states. But I'm giving you a version which is more understandable, which is more clear to you. If we apply force on let me just write it down, on an object, if we apply force on an object, then that object will also apply an equal force in opposite direction on us. An equal force on objects, an equal force on an equal force. Okay, other an equal force in opposite direction. And n, yeah, equal force in opposite direction. Sorry for that. In equal force in opposite direction. Opposite direction. So how to solve problems on tension and springs? I am coming to that. I'm coming to that. Don't worry. I'm coming to that on how to solve problems. I have that for you. Thank you. I love your curiosity, by the way. That's perfect. That is what we need in physics, by the way. And so let's just complete this part. Then I'm coming to how to solve problem. I'm coming to give you the problem solving techniques just after this part. So that object, okay, if we apply a force on an object, then that object will also apply an equal force in the opposite direction, on us. Yeah, that is Newton's third law, and that is what the normal reaction is. So normal reaction, we mostly talk about normal reaction when we place an object on the ground. So the normal reaction will always be perpendicular to the ground, right? Suppose the ground is like this, right, and we place an object over here, right? The object is like this. So the normal reaction will point upwards, right? It will not let the object sink into the ground. It is a force applied to the ground so that the object does not sink. Think about this in this manner, so that it is, it is prohibiting the object from sinking, right? The ground is like this. You place an object like this over here, so it will, prohibit, it will stop that object from sinking. It will apply the equal amount of force, which will be perpendicular to the surface. Now suppose the plane is like this, right, and we place an object over here, right? You place an object over here, and it is inclined. We place an object over here. So then the ground will also apply force in the perpendicular direction. That means towards here, right? So this is pretty amazing when we talk about inclined planes. So like we're not going to dive into that further, but we're going to move on towards the problem solving strategy, as you were asking earlier. So what is the problem solving strategy, right? What is the problem solving strategy? So we have first thing, let's write down the rules. Draw a diagram draw a diagram showing all forces acting on the particle. All forces acting on the particle. Right? Particle. So this diagram will be known as, this diagram will be called FBD. Okay, I have extended it too far away. Yep. This will be called free body diagram. Or FBD, basically abbreviation, short form, FBD. All right. So this is the first rule. Second rule is select convenient axis and take components. Select convenient x-axis and y-axis. Let me just write it down in a more correct manner. And y-axis. Select convenient x-axis and y-axis. Why are we doing that? Because we want to take components. Select convenient x-axis and y-axis, right? Because we want to minimize the component. Why convenience? minimize the components taken, right? This is why we are doing this. We want to minimize the components taken. Okay, let me just, okay, minimize the components taken. Let me write it down again in a better manner. Minimize. I am getting really a hard time from this pen. Okay, minimize. Yup. Minimize the components taken. What do we mean by this? Because think about this way. Suppose we have three forces acting on each other. Last part, don't understand? Okay. Minimize the components taken. I'm going to explain to you. Suppose we have 3.3 objects, three forces which are acting on each other. Suppose it is acting this way, it is acting this way, right? It is acting this way, right? This is 90 degree, by the way, right? And this is 120 degree. 120, yeah, 120 degree, let's say 120 degree. So what will be this? And this will be 90 plus 120 equals basically 210, 160 minus 210, 150 degree. Yeah. Okay. 150 degree. This will be 150 degree. Imagine this. Now we have to take a convenient angle. Suppose we took x-axis and y-axis like this. Suppose we consider this x-axis, right? And we made a y-axis accordingly, and we make y-axis accordingly like this. Then we have to take we would have to take component of this force along the suppose this is our x-axis. Suppose this is y-axis. Then we would have to take components of this force, right? We would have to take component of this force, and then we would have to solve it. But imagine if we had not done that. Imagine if we had not done that. Imagine if we had chosen. Imagine if we had chosen. Imagine if we had chosen the axis to be in such a manner that this would be y-axis, this would be x-axis, right? So we would have only had to take components of this vector only. So that is what we need to decide on of which vector we should take component and how to minimize the vector. If we could find 90 degree angle between two or three forces, then we will take that force as axis, because we will consider them as axis, because those will be necessary in solving the question. Otherwise, it will be a mess. It will be a hodgepodge of many different things. If you don't understand this, I'm gonna explain to you in upcoming example. Don't worry about this. But if you have any questions, please ask. Right? Don't be shy. So let's move on to the next question. Next point. Yeah, next point. Third point. What is third point? Balance the x components and y component. The x components and the y components. And the y components. Y components and get equations. Basically, that's what we're doing right now. Right? If you have anything, anything to ask, feel free, go ahead. So we just balance the equation just like we do in equilibrium. Basically, this was the analysis of the particle. But still equilibrium will exist. That means we have to balance the x component and y components. Okay, all right, let's move further. Next point. The next example, basically. So block of weight 100 Newton is suspended with the help of three strings as shown in the figure, and find the tension in each of the string. Right, let me just get my pen. Yeah, let's do this. Now this angle is 60 degree. I drew a parallel line. So what will be this angle? This angle will also be 60 degree. Vertically opposite angle, if I'm not wrong. Yeah, this angle will also be 60 degree. So now let's say T naught is the tension in the string. This will be, let's say this tension is called T naught, T0. We also say this as T naught. You will hear this term naught uh, as you move forward in your physics journey. This is T naught. This is tension in the and suppose the tension in the string OA is called T1, and suppose the tension in the string OB is called T2. Right? This is our terms. We are defining them. And let's move further. Okay, let's make a force diagram of the block. Let's make a force diagram of the block. Suppose this is called W, right? Yes, I also give homework. Yes, I also give homework. I will give you the homework after this lecture. You can check it out on All Academy website. They will have, this is a course which is available for free, so you can check out the homework. I have also given you the solution of that homework. That is, you should be able to solve that without any problem. That is perfectly fine. Those problems that I've given you in homework are necessary for your understanding, basically. So don't worry about that. Worry about, just keep learning what I'm showing you, and just keep writing down the notes. You will be fine. And also do the homework, of course. But let's move on further. Let's draw the free body diagram. What is the FBD of the block? FBD, free body diagram of the block. Okay. In free body diagram, look at this. What do we do in free body diagram? We do something like this. Suppose this is, okay, sorry. Suppose this is W, right? This is being pulled upwards by tension called T naught, right? And this is, weight is 100 Newton, so that this is pulled down by 100 Newton. 100 Newton, right? So there is no force on the right side, there's no force on the left side. So we have to balance the force on upwards and downwards. That is T naught equals 100 Newton, right? We have the value of T naught now. So now FDB for tension at O. Let's draw the force diagram for tension at O. Let's see what is happening at O, right? So this is O, our point. So let's see what is happening at O. First, let's take components. Let's take components, right? So if we take components along this axis, consider this y-axis, consider this x-axis. Suppose we take components. Let's be fast here. We take components. What is the components of? So this will be along. This will be T2 cos theta, because of course we're finding the base. This one. So this will be T2 cos theta. T2 cos 60, and this will be T2 sin 60. This will be T1, right? As we know, we have just taken the axis, and this will be T naught. We have all the forces, and we can now balance them. So T naught should be equal to T2 cos 60. That is equal to T2. Let's just balance this, right? Before we move further, should be equal to T2 by 2. Amazing, right? So T2 by 2 should be equal to T naught. And what is T naught? This is 100 Newton, as we have found here. Right? 100 Newton. So this will also be equal to 100 Newton. If this is equal to 100 Newton, then T2 equals 200 Newton. Very straightforward to here. If you need to ask anything, then go ahead. So this is basically T2 equals 200 Newton. And now let's balance T1 and T2 sin 60. Right? Let's balance the x-axis. So what will be x-axis? What will be the balancing equation of x-axis? T1 shall be equal to T2 sin 60. Amazing. Pretty straightforward. Nothing to worry about there. So T1 is equal to T2 sin 60. What is T2? Okay, if you have anything to add, go on. No. Okay, if you want to ask anything, just go ahead. I'm gonna move forward. T1 equal to 2 sine 60. What is T2? We have found T2 from the previous equation. If you have anything, please ask me. Because let me just explain it again. Let me explain it again. T naught equal to 100 Newton that we have found that by using this equation. Okay. And T naught equal to T2 sine T2 cos 60. T2 cos 60 as we have seen from the force diagram. But it will be equal to T2 by 2. Cos 60 is of course 1 by 2. So T2 by 2 shall be equal to T naught, which is 100 Newton, right? Which is 100 Newton, right? So T2 will be equal to 200 Newton. All okay? Perfect, perfect, perfect. I was thinking that I was not able to explain something properly, but that's perfect. So let's move on. T1 equal to T2 equal to T2 sine 60. So what is T2 sine? What is sine 60? T2 by sine 60 is root 3 by 2, and it is equal to T2 by T1 equals T2 root 3 by 2. What is T2? T2 is 200 Newton. That means 200 into root 3 by 2, right? That means, let's just cut it, 100 root 3. T1 equals 100 root 3. That means equal to 173.2 newtons. If I'm not wrong, that is it for this example. Pretty nice example. So this shows you when tension can be different. Suppose tension can be, tension can be different for each string, and tension can change as per the situation. As I told you earlier, tension cannot be equal to mg all the time, right? So this is what tension is. This is what tension means to be. So let's move on further. Let's move on to the next question. Example 4. A block of mass m rests on an inclined plane and is attached by a string to the wall. As shown in the figure, analyze the forces involved. Analyze the forces involved. Let's analyze them. We have to do nothing. We need to just analyze what is happening. Because if we do this perfectly, then we would have no problem solving other examples, other questions, right? Because all we need is to analyze them. All we need to do is get an understanding of how to analyze the forces. Suppose this is in this manner. I'm drawing it again. Okay. How about, yeah. I'm drawing them again. All right. I'm drawing them again. Just yeah. So this is like this. M, right? So this is what's happening here. So let's forget about string for a minute. Let's see what is happening with the normal reaction. Right? Let's see what is happening with the normal reaction. Pen. All right. So this, right? So this normal reaction will be perpendicular to the surface, as we all know. So let's see. So this will be, oh God. So this will be something like this, This will be normal reaction, which will be, perpendicular to the surface. Now, how do we analyze this? Suppose we draw a perpendicular, right? This is angle theta, and we drew a perpendicular. To this, right? So this angle would be also theta. That is, this is what is happening in this question. So the normal reaction is being applied perpendicular to the surface, but it is not perpendicular to the ground. Remember this. That's why I'm saying normal reaction is always perpendicular to the surface. It stops the object from sinking. So if you want to stop the object from sinking, then it will need to apply the normal reaction perpendicular to the surface, right? That is what's happening here. And weight, that means the weight of the body is pointing downwards. Mg. So what will be, let's say if this is, these are the axes, if these are the axes, if this is the axis, right, if axes are like this, right, this is x and this is y, if something like this is going on, then this angle will also be theta, and the force perpendicular to the plane would be equal to, mg cos theta, mg cos theta, right? And force parallel to the plane will be equal to mg sin theta, right? Write this down, because this is a very necessary example. And as we move further, we can see that we also have a string attached to this. If we have a string attached to this, then we would also have a tension which is pulling it back and keeping this in equilibrium. So as we can see that T shall be equal to mg sine theta, and n shall be equal to mg cos theta. This is the conclusion which we have drawn from this example. But this is more necessary to solidify your concept, solidify your understanding. And let's see. Yeah. So I believe that is it for today's class. I was about to discuss some other topic, but I think this is it for today's class. This will be lesson. This will be all if you need to understand what is going on in this topic. So in the next class we will be discussing friction, right? So I believe that is it for today's class. And if you have any questions, please feel free to ask me right now. If not, then we will end the stream. Let's see. I'll give you I'll give you 1 minute to ask anything which you have. After that, I will be stopping the stream, and we will meet again in the next lecture. Let's see. Class constant. Okay, the timetable of the class will be shared on Telegram, right? Class timings are very flexible. Sometimes math class happens, sometimes chemistry class happens, and sometimes physics class happens. Crazy IITs. Hello. Sorry, brother, you are late. I was just about to end the class. If you have anything, by the way, Ranjit, please ask me. And you can also watch this lecture again. There's no, all hope is not lost. All right. That would be great. Let's see. 10 more seconds. And, well, have a nice day then. Goodbye and have a nice day. I will see you in the next class. Till then, enjoy the day. Goodbye.